Welcome everyone. So first, let's understand about energy storage systems. Basically, energy storage system is a device that converts electrical energy from power systems into a form that can be stored for converting back to electrical energy when needed. Now, the storage technologies can be categorized into four major groups. Now, it depends on the form in which the store, like the energy is being stored inside the battery or inside the energy storage system. Now, considering that there are basically four types: electrochemical cells, electrochemical type of energy storage systems, electrical type of energy storage systems, mechanical energy storage systems, and chemical energy storage systems. Now, inside electrochemical energy storage systems, you can see there are so many types of examples basically like sodium sulfur batteries, flow batteries, lead acid batteries, sodium nickel chloride batteries, the most popular currently, which is lithium ion batteries, lithium sulfur batteries, nickel metal hydride batteries, nickel cadmium batteries, metal air batteries. This is been categorized inside electrochemical cell because the energy which is being stored inside it's in form of electrochemical energy. Similarly, there is electrical energy storage systems like superconducting magnet energy storage systems, supercapacitors. Then in mechanical energy storage systems, there are several types like compressed air energy storage system, flywheel energy storage system, liquid air energy storage systems, pumped hydro energy storage systems, and inside chemical, hydrogen fuel cell energy storage system is there. Now, whenever we are considering cells, so the first thing that came to our mind is basically electrochemical cells. Now, majorly we will be focusing towards electrochemical cells, mainly lithium-ion cells. Now, if we consider any type of batteries, there are basically two type of cells or batteries that we can consider. One is primary and another one is secondary. Now, what is primary? Primary types means some non-rechargeable batteries, which can be used for occasional like toys, flashlights, smoke alarms, etc. And they are also used in devices in which charging isn't possible, like pacemakers, wristwatches, hearing aids, such kind of applications. Now, there is also a type of battery which is secondary cells or rechargeable batteries that can be used in applications where is a need for a regular power source like mobile phones, laptop, automotive devices, and so on. Majorly in this group, lithium-ion batteries, which is a type of electrochemical cell, is the most popular one. There are few reasons behind it. Now, as we know, alkali metals readily give up electrons, and lithium-ion or lithium has the lowest reduction potential in this group. This means that lithium batteries have a relatively high voltage compared to other type of batteries, and higher voltage always translates to storing more energy. That's why this lithium ion batteries or lithium ion can be used in both rechargeable and non-rechargeable batteries. Now let's discuss about lithium ion batteries, how the lithium ion batteries basically works. Now every type of battery basically has three major parts, right? Three or four major parts. What are those major parts? One is electrodes. It can be anode or cathode based on the positive electrode or negative electrode. Then you have separator to separate both electrodes so that it can't create a short circuit. And to exchange ions through the separator, there are electrolytes, which is basically the medium to transfer ions from one end to another end, right? Now, in case of lithium ion batteries, basically the cathode material is constructed by lithium metal oxide. Now there can be different based on different chemistries. There can be different type of lithium ion batteries. Right? So similarly, in lithium ion batteries, generally what we consider, if we consider any metal as M, so the cathode material is generally made up of lithium metal oxide, right? Lithium metal oxide, Li. I am generalizing the metal, LiMo, right? Then in the anode side, generally the anode material is graphite or a form of carbon, basically C6. Now I will explain you about how the chemical reactions happens and what are the chemical reactions that happens during charging and discharging process. But before that, let me tell you about the parts or different components of any battery. So the anode or the negative electrode is basically considered as a reducing or fuel electrode, which gives up electron to the external circuit and is oxidized during the electrochemical reactions. Similarly, cathode, as the name suggests, is a positive electrode, the oxidizing electrode basically, which accepts electron from the external circuit and is reduced during the electrochemical reaction. As you know, there are electrolytes to exchange the ions. So it's basically develop a ionic conductivity, which is basically ionic conductor, which provides the medium for transfer of charge as ions inside the cell between the anode and cathode. Practically, non-metals are mainly used as an anode metal. That's why you can see graphite or carbon is being used in anode material. However, most of the common cathode materials are metallic oxide. Other cathode materials such as halogens and oxyhalides, sulfurs, and its oxides are also used for special type of batteries. The electrolyte must have a good conductivity but not to be electronically conductive, as this would cause internal short circuit between cathode and anode. Physically, the anode and cathode electrodes are electronically isolated in cell to prevent internal short circuiting, but are surrounded by electrolytes. In practical cell design, a separator material is used to separate the anode and cathode electrodes in mechanical form. That's why you can see, which is this part basically. The most advantageous combination of this anode and cathode materials are those that will be lightest and give a high cell voltage of capacity, right? Now, as we were discussing about lithium-ion batteries, and lithium metal oxide is being used as a cathode material and graphite is used as an anode material. Now, let's understand what happens when this charging process starts inside a lithium-ion cell. Okay. Let's first discuss about charging. Okay. Now, in cathode, as you have lithium metal oxide or LiMO2, okay, let's consider its charging, right? So we have a voltage source. Right. So during charging, what will happen? The current direction will be towards the cathode, right? That means the electron flow will be just opposite to that. So it will flow towards anode, right? Now let's see what happens during charging. Now in cathode, as you have lithium metal oxide, which will break down in lithium ions plus the metal oxide, and as lithium ion is created, so there will be an electron as well, free electron as well. Right? Now, in anode side, just the opposite reaction happens. So inside anode, already there was graphite. Now, whatever lithium ions and electron is being created inside cathode, it will flow towards the anode, right? And it will create an intermediate compound, which is called lithiated carbon, or the formula or the this thing is LiC6. Okay, it's an intermediate compound. Now, during discharge time, so as you have a load here, a resistance, let's say, so current will flow from cathode to anode side, right? This direction. So the electron flow will also be opposite to that. So previously it was following this side. Now it will flow from anode side to cathode side, right? So what happens generally, the reactions just get opposite. So whatever in cathode, so let's first discuss about anode. So in anode, lithiated carbon basically breaks down into graphite, lithium ion, and electron again. And this lithium ion and electrons flows to cathode side and create again that lithium metal oxide reacting with this metal oxide part. Right. Generally, in batteries, in lithium ion batteries, some kind of slurry or some kind of thick uh, slurry kind of material is being prepared, which is being pasted over different metals, right? So in cathode, basically they use aluminum with over that aluminum sheet, they pasted those slurry. And similarly, in anode side, they keep a copper uh, metal, and over that they paste the anode slurry, which is basically the graphite. Okay, and they put some separator materials to separate those things. Okay, basically this is the reaction.